In this video, we want to find the equation of a hyperbola, given information here, foci at -5, 0 and 5, 0, and vertex at 3, 0. But because the foci lie on a horizontal line, in this case, the x-axis, we know the form of the equation has to be x squared over a squared minus y squared over b squared equals to 1. Had the foci been at, say, 0, -5, and 0, 5, then it'd be the other way around. We'd have a plus here and a minus over here with the x term, and the a squared would be under the y squared, and we proceed from there. But from this information, it's clear that the center is at the origin. The transverse axis is the x-axis here. We have a vertex at 3, 0. Because the distance of this vertex from the origin is 3, we know that a is equal to 3. And because the distance of a focus, or the foci from the origin is 5, we know that c is equal to 5. And then associated with the hyperbola, a little bit different than with the ellipse, b squared is equal to c squared minus a squared. So in this case we have c squared then is 25, a squared, a is 3, so this would be 9. So this is 16. We want to point out to you here, the equation of the hyperbola is very similar to that of the ellipse. The ellipse has a plus sign here, but for the ellipse, the a has to be greater than b. That's how you decide what type you're going to have, whether you're going to have a horizontal ellipse or a vertical. For the hyperbola, it doesn't matter. A and b could be the same value. A could be greater, a could be less than, it doesn't matter. The key is going to be the minus sign. Where is the minus sign? So here we have a horizontal hyperbola. Transverse axis passes through the origin, and it is the x-axis. So with this information, we have the equation. And that's going to be x squared over a squared. This is going to be 9. 3 squared is 9. Minus y squared over b squared. B squared is 16. This is your equation. Now this doesn't ask for the graph, but just to show you, because we'll go into one more complicated later on. Sometimes they'll ask you for the asymptotes. That's something the ellipse didn't have. The hyperbola has asymptotes. So the way you find the asymptotes is basically, shortcut is to take the equation. Now for this one we're finished. As far as what they asked, that's it. So if you want to continue with something else, go ahead, but I want to give you a little bit more information. X squared over 9 minus y squared over 16. If you set this equal to 0, in other words, replace 1 by 0, this is a shortcut to get the asymptotes. Simply solve this equation for y squared, and then take the square root. So if I do this, take this over to this side, but I'm going to leave it on the left side here. And then I multiply by 16, so this gives me 16 over 9. So we have y squared is equal to 16 over 9 times x. And we take the square root, plus or minus. So this gives me plus or minus 4/3 times x. Those are the asymptotes of the hyperbola. Like I said, this is all we need for this one. This is what the problem wanted. But I'm just giving you some extra information, because we'll use that in the next problem, next video. And this is your equation again. X squared over 9 minus y squared over 16 is equal to 1. So I've kind of set this one up. The origin is right here. And since a is equal to 3, we go 3 units to the right. So the red mark there is one vertex, and then 3 units to the left. There's the other vertex. Now it turns out that for the hyperbola, and you don't have to do that, but if you want to be more accurate, if you draw this rectangle that I have here, in other words, go up 4 b units. In this case, b squared is equal to 16, so b is equal to 4. So basically I went 4 units up here, 4 units down, and then I draw this rectangle through that point. And notice down through the vertex on that side and the vertex on this side all the way. And then 4 units down also turns out that the asymptotes will pass through the corners of this rectangle. The focus, of course, is going to be over here. 5, 0 there. And negative 5, 0 over here. One vertex here. And then the graph approaches the asymptote. And from this vertex, the graph goes up, approaches that asymptote. Same thing over here. And now to verify this for you, let me just do this. Y equal to 4/3 x. That's this asymptote here. And then y equal to minus 4/3 x is this asymptote over here. It's lining this way. So notice, if I replace, let's take the first one here, let's take this one here. If I replace the x by 3, let's say we want to draw the graph of this line asymptote. I already have it drawn, but just to show you, replace the x by 3, we get y equal to 4. So that means if I go 3 units to the right, I go 4 units up to get on the line, which of course is the corner of that rectangle. And go back the other way. If I replace the x by negative 3, negative 3's cancel out, and I get negative left, negative 4. So that tells me that if I go 3 units to the left, the y value is, to get on the line, is negative 4, and which is right there at the corner of the rectangle. So that's why this works. So anytime you want to be a little bit more accurate with the graph, especially the ones that have center at the origin, you can draw this rectangle this way, and then the asymptotes will pass through the corners of the rectangle. Thanks for watching. We'll see you next time.